I wanted to take another look at this example that we graphed. Y is equal to -4 cosine of pi x. To be able to take a look at that graph versus our regular plain, I call them plain vanilla cosine curves, which y is equal to the cos of x, which is in the red line on this graph here. So here's our regular cosine function, and here is the cos function that we just graphed in the video before this. So here, if we look here, this is between x's -2 and +2. So this is the graph that we generated. And this is our regular cosine curve. So we can see for the regular cos, let's just ignore these negative x values right now. For regular cosine, we would start when x is 0, we would start at 1, then we would decrease to pi, and then increase to 1 again at 2 pi, which is 1 complete period. So there's a complete period for our regular cosine function. And if we take a look at what's going on here between 0 and 2 pi, or if we converted the pi to numbers, we would go from 0, 2 times 3.14 approximately, for pi would give us 6.2. So we're looking here between 0 to about 6. And that's normally 1 period. But we can see now for the function that we graphed, I've darkened the 1 loop we did between 0 and 2. We had 1 complete period because our period was changed. This pi here changed our period from 2 pi to the 2. So that if you look here, in this normal 2 pi where we would have 1 period, for our function we have a little bit more than 3, which makes sense because 2 times 3 is 6 and 2 pi is a little bit more than 6. So we can see how when we change up the period, we might have a situation where within our normal 2 pi, we have more complete cycles than just the 1. The other thing to point out is in what's going on with our max and mins. For normal plain vanilla cosine, I shouldn't call it normal, just the basic one, our max is 1 and our min is -1, our amplitude being 1. In the function we graphed, our max is 4, min is -4 because we've changed our amplitude. It's now 4. So you can see our graphs are taller, longer than the regular cosine function. And then we're in a regular cos function. We start at our max and decline. Here, because we have this negative sign, we've flipped our cosine. So instead of starting at the max and declining, we start at the min here. We start and we increase. So as I said, I thought it would be useful to take a look at what we produced in conjunction with a plain cosine function to see what these change in amplitudes and periods imply.